we introduced the study and design of a shape-shifting wall display. We asked two questions about large displays. Would people choose a flat display for given interactive scenarios? And if not, what are the display shapes they'll actually prefer? We set out to investigate these questions in a design study, asking people to freely form different display shapes according to various screen content conditions. Participants were introduced to various interactive scenarios, presented by different content and distance conditions. We used 6 different content types typically shown on large displays. We used 4 distances of individuals and pairs standing in front of the display. Participants were then asked to design display shapes to best match the interactive scenario. We optically tracked the participants and their display shapes designs. Here are some examples of participants' screen shapes designs in different scenarios. Immersive games, wide format movies, full display applications such as map viewers, multiple windows running different applications, private information such as entering credit card numbers. 16 participants designed a large variety of screen shapes, each designing for 24 different interactive scenarios. The designs demonstrate that our participants had chosen not to use a flat display for most of the given interactive scenarios. The designs also inform us of the shapes we could include in our shape-shifting wall display prototype. Our implementation uses a Connect camera, tracking cameras, projectors, and 3 slim screens. Each screen is mounted on a Roomba mobile robot that can be repositioned. The Connect detects gestures, while the tracking cameras track screen positions to help fine-tune their positions. We begin with gestures. A group just finished collaborating over a flat screen. They shift to individual work with a user gesture to change the display to 3 separate screens, 1 per person. When his collaborators leave, the person gestures for a concave screen shape, which he prefers for personal work. Our second technique automatically customizes its shape to best fit the content being displayed. In this example, the display detects private content and becomes concave to shield the person's work. Here the display detects widescreen video and becomes flat to optimize viewing. While for games, a concave shape provides a more immersive experience. Our third technique automatically customizes its shape to fit the spatial relationships of the people around it. In this sequence, the display detects an approaching person and changes its shape to support personal work. When a second person enters and stands side by side to the first person, it partially flattens to support collaboration. We will now see how the display supports mixed focus collaboration involving both individual and group work. 2 people are planning a trip. Each goes to the side to do some individual work, but they can still monitor the shared map at its center and each other's actions. When they come back to the center, the display flattens for full collaboration. Managing shape changes is important, as the system may infer an incorrect shape. We allow people to explicitly override any changes through a cancel gesture.